Hey folks, my name is Ravish and welcome back to another video in the series of DevOps real-time interviews. Now, today we have a profile with us today. So the person is having around 7+ years of experience in IT with close to 4+ years of experience in DevOps and cloud related services. The person is having good communication skills. We started from the daily roles and responsibilities, then we asked about the tech stack, what exactly the person works on, and we have concentrated on AWS mostly, the ECS part, the API gateway, code build, code pipeline, a bit on Ansible too, and a bit on Terraform and then EKS. So that's what we have asked. At the end, we have asked two scenario based questions on EKS, on Kubernetes, how the person can solve that, and that would be about the interview. Alright, so if you're watching this video on any other platform, make sure to check out the first comment, the pinned comment, to check the full video. Alright, so without further ado, let's get started.
Yeah, so thank you for the opportunity to discuss my skills. Yeah, so my name is. I'm deeply passionate about. Yeah, I've been working as a DevOps engineer for some time now, and I'm deeply passionate about bridging the gap between software development and operations. And I've been able to achieve streamlined and efficient and reliable systems for the past 7 years that I have been working. Then okay, yeah. So recently I got a role with Big Real, and I've been there for about 2 years, over 2 years. So in my most recent role, I focused on automating and optimizing deployment of processes. Yeah. So my key responsibility was managing our CI/CD pipelines, as a DevOps engineer, and I used tools like Jenkins. I used GitLab and the likes, and I've been able to do all of this. I've been able to significantly enhance our deployment frequency and also reduce downtimes to the barest minimum. So I have experience with cloud computing, particularly with AWS. I have successfully managed and optimize cloud resources. Yeah, I've used resources like EC2, S3, and RDS. Yeah, so basically, I've handled a couple of projects, using AWS. So in one of the projects that I did, I think I led the migration of a critical application, yeah, on AWS to the cloud, and this also helped to improve scalability, yeah, and also like I said earlier, like help to reduce downtime and improve efficiency in what I do. So yeah, I've also worked with Docker, yeah, which is basically for containerization, yeah, and then Kubernetes for orchestration, and a whole lot of other tools. And I've actually orchestrated a containerized like a microservices architecture. Yeah, basically, I've done things like that, and yeah. So basically, I think that's it for my experience as a DevOps engineer.
Okay, okay, fair enough. So, can you just walk me through the um, daily roles and responsibilities that you have?
That I have, I don't get. I'm trying to understand. What do you mean roles and responsibilities that I have?
Daily responsibilities, like what exactly do you do on a daily basis with respect to your project or a product?
Okay, yeah. So the roles and what I do on a daily basis as a DevOps engineer. Okay, yeah. So the first thing I start my day by checking our monitoring tools to ensure that all systems are running smoothly. Yeah. So by monitoring tools, I use Grafana. I check logs. I use Kibana just to make sure that there's no issues. Yeah, basically. So that's how my day starts. So I check the monitoring tools to be sure that everything is working fine and there are no potential issues. Yeah, so that's how I start my day. And then of course we also jump on ongoing projects. We do project from time to time. So after checking the monitoring tools, like I said earlier, I jump on projects, and then we work on existing projects, and there are times that we have to start new project from time to time. So yeah, and of course, collaboration is very crucial to what I do as a DevOps engineer. So I collaborate with different teams to ensure the success of whatever projects that we work on. Yeah, basically I think that's it, except you have more specific questions. Yeah, because I improve our CI/CD pipelines and all of that. So I don't know if you have more specific questions to ask.
Okay, so so the application that you work on, the project that you work on, what is the tech stack of this project?
Sorry,
What is the tech stack of your project?
what is it? I'm
Tech
sorry,
stack,
I didn't get.
technical stack. I mean, what are the tools and technologies that you use for this project?
Okay, yeah. So I use CI/CD tools like Jenkins, like I mentioned earlier. Yeah, for so our stack is basically like carefully chosen to make sure that we maximize efficiency and reliability, and to reduce errors as much as possible. Firstly, our infrastructure, the cloud infrastructure we use is basically AWS, like I mentioned earlier, and this includes services like EC2 for computing power, S3 for storage, and RDS for database management, basically. So, the flexibility and scalability of AWS is actually very key for us in my environment, and allows us to adapt to changing demands, yeah, of the system, basically. And for our CI/CD pipelines, we rely on Jenkins, like I said. I use Jenkins, and it's a powerful tool that automates our processes. Yeah, so it automates the deployment process that we do from end to end. So it ensures that there's an end-to-end process from start to finish. And as a result of this, we have an error-free process, and it's also consistent. We keeps going on day by day. So Jenkins integrates seamlessly with our version control system, which is Git. We use GitHub for version control, and this setup ensures that our code base is always up to date, and deployment also happens smoothly, without errors, like I said earlier. Then we use Docker for containerization, which allows us to package our applications and our environment into containers, which is also what we do on a daily basis. So this helps to make our applications as portable as possible, and also consistent, across different development. Yeah, basically. So these are significantly reduced manual problems because everything is automated. So we reduce manual processes to the barest minimum. So, like I said earlier, for monitoring and logging, I use Prometheus and Grafana. So this pairing gives us real-time insights into the system's performance. So every time we have visibility into how our systems perform, what are the errors, and then we're able to quickly identify and address any issues. Yeah, because sometimes you can have issues, but we identify it beforehand, and we were able to really address them. Yeah, so we also use Elasticsearch. Yeah, we use Elasticsearch. We use Kibana as well for logging and data visualization. That's what we use Kibana for, and this has been instrumental in improving our debugging process.
Okay,
Yeah.
okay. So your application is written
So,
in what language?
sorry?
Your application is written on what language?
Okay, it's actually a Java based
Java
application.
based application. Okay. So can you just walk me through the whole pipeline end to end? How does it start from step one? If you're using Jenkins, how does it start from step one till production? What are all the steps and or stages that happens in your pipeline? Can you just walk me through that one by one?
Okay, so I should walk you through all the stages from end to
Yes.
end when we use pipeline to
Yes.
automate our processes. Okay, yeah. Basically, like I said earlier, step one is to there are codes written, yeah, and
Mm-hmm.
committed. Our developers write codes, and they commit the codes to GitHub, and then which is like a version control system, like I said earlier. Um, so we use branching in Git, so that every feature, every bug, like every bug is quickly fixed because there are times that we can have bugs, and then we make sure that they are fixed as quickly as possible. So so once development is complete, yeah, when the developers do what they are meant to do, so we pull the source codes from Git, to merge them into the main branch that we're going to be working from. And as soon as this pull is done, then our automated pipeline, of course, the CI/CD pipeline kicks in. So which is Jenkins, like I said earlier, and Jenkins automatically runs a series of tests here on the new code, the code that was committed by the developers, which we pulled. So this includes unit tests, it includes integration tests and different kinds of tests which are done to ensure that everything is fine, basically. So the tests are actually very crucial to help us catch bugs, to ensure that there are no errors in the codes that have been written, basically, and also to test code quality as well. So if the test passes, it is reviewed by a peer. Like peer review is basically it's a part of what we do, right? So it's to ensure that there are at least two sets of eyes, so that's why it's not just one person. So yeah, so a peer looks at it before it goes into production. So this helps in catching issues, like I said earlier, because in my environment, we always make sure that we reduce errors to the barest minimum. And so once the code is approved and merged into the main branch, we trigger the CI/CD pipeline. Yeah, so we use Docker here for containerization. Docker packages the application, and its dependencies are actually put in a container, which helps in maintaining consistency across different environments. So after this step, we deploy to our staging environment, which is like a replica of our production environment here, which it was crafted that way, and it gives like a safe space to test our changes in real time, in real world settings, so that if there are issues, we can actually check. And we perform additional tests. We perform tests including UI tests, acceptance tests, and just to ensure that everything works as expected. So if everything goes well in the staging environment, the changes are automatically deployed to production at this stage. So this is actually done in like a phased manner, which helps us to like monitor our processes, and the performance of the application. And at this stage, if there are issues, we can quickly roll back. If we discover that there's something not right, we can roll back, and then so yeah, so throughout this process, like I said earlier, we use our Grafana and Prometheus to monitor logs, just to ensure that there are no errors, that there is no issue, and just to be sure that everything is under control. So yeah, so what else? So and that's the entire process. So from a code commit by the developers to production deployment, and so this pipeline
Okay.
actually
Okay.
greatly improved our frequency of deployment and helped us to maintain a high standard of quality and reliability, and also to reduce errors as much as possible to the barest minimum. Thank you.
Okay. So this deployment is happening or where on EC2 instances or Kubernetes cluster?
Deployment is happening on Kubernetes clusters.
Okay. Okay. Okay, so you are comfortable in AWS, right?
Yeah, yes, I am.
Okay, cool. So let's talk about ECS. How would you design a highly available and scalable architecture using Amazon ECS for containerized application?
Okay, so how I'm going to design a scalable, I'm sorry, a scalable ECS. Amazon is ECS for.
ECS, yes.
Oh, okay. Yeah. So basically, for scalable applications, in my environment, what we currently do is this. Um, comment. Let me see. Okay. So firstly, I start by setting up EC2 clusters, yeah, across multiple availability zones within an AWS region. So, which is crucial for redundancy, so that if one availability zone goes down, the others can actually pick up, and that way there's no downtime, the application is always available. Yes. So within these clusters, I use EC2 to manage Docker containers for the applications, right? And containers are great because they help to package the codes, yeah, and all the dependencies of the code, so that applications can run quickly and reliably from one computing environment to the other. So then I'm going to implement an auto scaling policy for the EC2 services. So the reason I do this is to handle varying loads. Yeah, so this policy would adjust the number of active containers based on demand, ensuring that the application can actually scale up efficiently during peak times, and scale down to also save resources when there's no demand. Yeah, so just to strike a balance. So to enhance availability, yeah, I think I use a load balancer as well. The one we use is an application load balancer, yeah, just to ensure that
Okay.
you know enhanced availability. So this would help to distribute incoming traffic, across multiple targets and into multiple availability zones, like I said earlier. And it also helps in balancing the load and to achieve fault tolerance, basically. So for the database, I
Um,
think I'm
that's
gonna.
that's that's fine. Let's not talk about the database right now. But yeah, I would leverage ECS clusters spread across multiple availability zone, which you talked about. I can also utilize auto scaling group for ECS task and employ elastic load balancer to distribute the traffic. That also I can do. And additionally, if you
Yeah.
want, you can configure ECS service auto recovery for fault tolerance. That's an idea of it.
Yeah.
Okay. Um, let's talk about API gateway. Can you explain me the key consideration when designing a RESTful API using Amazon API gateway for a microservices architecture?
Okay. Amazon API gateway for architectures.
Microservice architecture.
Oh, microservice architecture. Um, Let me see. For microservice architecture. Let me see. Okay, so basically for microservice architecture, Amazon API gateway actually plays a very crucial role. You know, so it helps to manage calls to microservices, to ensure that there's a smooth and there's a smooth interaction, yeah, basically. So now let me walk you through the key components. That's okay. So firstly, the ability to define RESTful APIs. Yeah, I'm gonna say that. I think that that's a major component because we use API gateways to create, to publish, to maintain, and to secure APIs at any scale, basically. So this allows my microservices to, like I said earlier, to communicate with each other and with external clients effectively and efficiently. So, for example, it's like having like a well organized, maybe like a postal system. Yeah, if I can use that example, that ensures that every message, maybe like it gets to where you need it to go, something of that nature. So another key component is the request and the response transformation feature. Yeah, something like that. So with API gateway, we can transform incoming requests before passing them to the backend services, and we transform the responses back, yeah, the responses back in a desired format before sending them to the clients, yeah. And another thing is the authorization and access control, yeah. So we use API gateway to set up authorization and to set up access control at the API level. So here we use AWS IAM, which is identity and access management, by assigning roles, and policies, by using lambda authorizers, basically. So this gives us the flexibility that we need to secure our microservices, because we don't want just anybody to have access to our application. So it defines who can access the application at every point in time. So another thing is I think rate limiting, yeah, is another thing that we do. So API gateways can actually allow us to throttle requests, yes, to prevent attacks, and help to like manage traffic, so that the backend services are not, I'm gonna say, overwhelmed, yeah, so that there isn't so much pressure on the backend services. So this helps to maintain the reliability of the microservices, yeah, especially when you have high traffic. So it makes sure that there's availability of the microservices. What else? What else? What else? What else? Um, so I think
Yeah,
integration with it.
I think that would be fine. So when you talk about the consideration, it basically includes proper authentication and authorization mechanisms for API versioning, caching strategies, error handling, and designing resource URIs to align RESTful principles. Additionally, you can
Yeah,
optimize for low latency and high throughput because that's essential. That's pretty much
yeah,
about it.
and integration with AWS Lambda too. That's another thing that we do. It's
Okay.
fine.
In the current project or in the past, have you ever worked on AWS code commit and code deploy?
Yes, yes,
Can you
I
just
think I
walk me?
have.
Okay. Can you just describe the process of integrating Amazon code commit with Amazon code deploy for CD? If you can highlight the best practices, that would be great.
Okay, code commit and code.
Deploy.
Okay, so code deploy. Let
I
me
mean,
let me think. I
process of
think I have
integrating.
process of done what?
Process of integrating Amazon code commit
Okay,
with
process of
AWS
integrating.
code
Yeah,
deploy.
using Amazon. Okay. Let me see. Yeah, I think I should have done some. Let me think. Okay. Yeah. So for AWS code commit. Yeah, just trying to remember. Okay, so AWS code commit is like Amazon's source control services, if I'm not mistaken. So here we store our repository. Like it works like GitHub, which is like a source code manager, like I said earlier, and a big bucket. So the first step is to basically to ensure that our code base is properly stored and managed in the AWS code commit, and this is actually very good for, version control, which like because it's similar to how the Git works, like I said. Um, so basically, I find it very reliable. So we use this, especially when working on AWS ecosystems generally and basically. So once the code is in code commit, the next step would be basically I think setting up the AWS code pipeline. Yeah, basically.
Code
So
build.
this act,
Code build will come next.
sorry. Yeah, so this acts like the backbone of all our CI/CD processes. So I create a pipeline that triggers um, triggers on every commit to the main branch, of my code commit repository, because there are branches as well, just like I explained earlier. So this is actually very configurable with the code pipeline settings, that have been specified. So the pipeline itself can have some stages. So the first stage is basically the source stage. Yeah, I think if I remember correctly. So where the code pipeline pulls the latest code from the code commits, the codes that have been committed already, they are pulled. So after pulling the code, I think the next thing will be to set up a build stage using AWS code build, yeah, to build the codes that, and we can also use another build service, but in this case, I would go for AWS code build. And this stage actually compiles, I think the code, yeah, the code. At this point, we also run tests, because we have to make sure that our codes are great and good to go, and there won't be errors. And we also create like a deployable artifact, yeah, basically, like a zip file or whatever we decide to create, at that point. So the most crucial part will be the development stage, which is I think where the AWS code deploy, that's where it comes in, because at this point we have done other things and it's time to deploy. So the code deploy automates the deployment of our application to various what's the word now, to various compute services, yeah, basically like AWS, EC2, Lambda, and the likes. Yeah, so basically I can set up like a code deploy a code deploy application and a deployment group to define the deployment configuration. So this can include like I think like specifying the deployment type, that I need at this point. Things like, okay, maybe the blue green, and then configure the necessary hooks and scripts for successful deployment, because at this point we have to ensure that deployment is basically successful. So once this is set up, so every time a change is actually pushed to the code commit repository, it's automatically triggers the pipeline in the code pipeline. So the code is built at this point and it's tested, and if everything actually works out at this stage, code deploy automatically deploys the new version of the application to the specified target.
Okay.
So basically here we always ensure that, like I said earlier, monitoring tools, there's monitoring at every stage, and then we can roll back if there are issues and all of that. So basically that's it.
Okay. Okay. Just one quick request. Can we keep answers to the point and let's not go into the description as of now? Okay. Let's keep them to the point. Okay.
Okay,
Okay.
all right.
So, in your profile, or before moving the question further, the best practices will be using deployment groups, blue-green deployment, and leveraging pre and post
Yeah.
deployment hooks for validation. This is one of the best practices that you can use. Okay. Let's move on to the other thing that you have mentioned in your profile. Um, okay. So you have written Ansible. So how comfortable are you in Ansible?
Mm, I think I'll give myself like a seven, or an eight. Yeah. So
Okay. Okay. What exactly are you doing with Ansible in your current project?
Okay, in my current project, yeah, so I've used Ansible for a number of projects, but let me think of a recent project that I
Okay.
actually did with Ansible. Let me think. Um, okay, yeah, so I think I have I think I've gotten one. So let me try and since you said I should go straight to the point, I hope I will not, I'll just keep to that. Yeah. So in my current project, I have actually, like I said, I use Ansible a lot of times, and Ansible has actually helped me to enhance because it's an automation and a configuration tool. So it has helped to enhance our automation and configuration management process. Okay, so I use Ansible for a number of things. For example, I write Ansible playbooks to automate and set up the configuration of our servers, in my environment. So because Ansible uses a declarative language, yeah, so I can easily define the state of my systems, yeah, basically. And Ansible ensures that the system matches this state. So this approach helps to, you know, um, reduce time and effort. So another area where I have used Ansible recently is I think for integration and for deployment. Yeah, I have integrated Ansible with my CI/CD pipelines to automate, yeah, my deployment process. For example, when a new version of an application is ready to be deployed, Ansible playbooks are actually triggered as part of the pipeline to deploy the application to yeah, to deploy the application to the deployment, to the testing, or to the production phase. Yeah, so this makes it very fast to make it makes deployment faster and more consistent and also error free too. So another thing I have done with Ansible, if I remember, is I've used Ansible to orchestrate multi-tier IT application environment, by I think defining the interrelationships between different services in their infrastructure. So I can use Ansible to ensure that the application stack is, I think I would say, deployed in the correct order. And let me see. And yeah, also to ensure that configuration is done correctly. So this helps to maintain the integrity and the performance of our applications. I don't know if I answered your question. I also use Ansible in terms of security, by
Okay.
automating and
Uh, Sorry to interrupt, but in what scenarios would you choose Ansible for infrastructure management?
in what
In what scenarios would you choose Ansible for infrastructure management or infrastructure automation?
infrastructure automation. Okay, yeah. So in a number of scenarios, like I highlighted, because in my environment we are very big on error free processes, and we're also big on consistency in what we do in our processes. So basically, I'm gonna use Ansible in, let me see, considering that it's a tool that is like easy to set up and get started with. So it's also very simple, and it's I think it's agentless. Yeah, it has an agentless architecture, and that makes it like a great choice for teams that want to adopt automation, and that's the reason why we have adopted it. Um, yeah, also because it uses YAML, the language for its playbook, which is also quite straightforward and readable. So because of it, we use it to onboard new team members, and those who are not really experienced in scripting and they want to come into our environment. So we use Ansible to basically onboard them and ensure that they are integrated as soon as possible. So another scenario is maybe when I'm working on configuration management, across like a diverse set of environment. Yeah, Ansible can actually ensure that the servers and the systems are configured consistently, regardless of their locations and their types, basically. So whether it's maybe cloud environment, virtual machines, or the likes, Ansible can actually ensure that all these environments are integrated seamlessly. So I'm going to choose Ansible in this scenario as well. Then I'm also going to use Ansible where I need to perform like a multi-tier application, basically. So because it's an orchestration tool, like I said earlier. So here it can help us define and automate deployment processes for applications that have, I would say, complex interdependencies. So Ansible can actually allow me to ensure that each of the components is, I'm going to say, deployed in the correct order, and and in the correct order of configuration, basically, so which is crucial for the overall performance and the reliability of our applications. And also in the case of security and compliance, so I'm going to use yeah, Ansible. It's my go-to choice because it has the ability to like automate patching and to enforce I think security standards, yeah, basically. So when I want to enforce compliance and security, I'm going to ensure that I use Ansible across our infrastructure because it helps to maintain compliance with different IT security regulations. So yeah, I think basically that's it.
Okay. When we talk about ECS, we have two launch types, right? ECS Farget and ECS EC2.
Yeah.
When would you choose over the other?
Yeah, I think I'm going to choose EC2.
Why?
Yeah, so yeah, apart from the fact that I've actually worked more with EC2.
Do you know how
I,
Fargate
I, I
works?
think, sorry,
Do you know how Fargate works?
do I know how what?
Fargate,
Okay.
AWS Fargate works. ECS Fargate works.
ECS Fargate.
How does it work?
ECS Fargate.
Yes.
Oh, okay. Let me see. Yeah, I've used ECS Fargate before, but let me see. Let me think of how best to really summarize how it works. Um, yeah, so basically, I'm going to say that ECS Fargate is like how will I put it, like um it's like a seamless, let me see, um okay, it's a highly efficient and innovative service, right, for running containers. Okay, let me try and see if I can explain how it works, and the few times I think I have used it. Okay, so basically, Fargate eliminates the need to manage our servers and I think our clusters. Yeah, so it helps to manage our servers and our clusters for running containerized applications. And I think the advantage of this is it allows me as a DevOps engineer to focus on designing and building my applications without, I think, worrying about the underlying infrastructure. So I can just focus on the major work, basically. So when I use Fargate, I think I start by packaging my application in containers, yeah. And then I also define my applications in terms of CPU, memory setup, and the network and the IAM policies, identity and access management. And the Fargate can help to like take care of the rest. And it also helps to, if I remember correctly, yeah, to allocate resources. Yeah, so it can also help to launch containers and I think manage their life cycle rather. I think I would say that as well. So this can all be achieved without me having to provision, configure, or to scale clusters of virtual machines. Yeah, basically. So let me think what else. So I think another key aspect is the integration with other AWS services. Yeah, yeah, you can integrate seamlessly with other AWS services, and for example, yeah, the Amazon ECS, yeah, that's the Elastic Container Service, and the Amazon EKS as well. It integrates seamlessly with those things, so those applications rather. So it means I can also use Fargate to run containers that are managed by either ECS or EKS. So I think the choice should basically depend on, okay, whether I'm looking for simplicity or whether I'm looking for deep AWS integration or flexibility and maybe Kubernetes compatibility, in that case, which is the EKS. So also another aspect would be I think maybe the pricing model. Yeah, the pricing model should be another important aspect. Because with Fargate, I think you only pay for the resources that your containerized application uses. Yeah, as against paying for things that you're not really using, at that point. So this model is, I think, is based on the amount of CPU and memory resources that your container actually consumes. So it's I think I'm gonna say it's a very cost effective approach based on that, and yeah, so I'm gonna choose the Fargate because of its cost effectiveness. So that I'm not, because as much as possible we have to ensure that we minimize resources. Very very well, and let me see.
No, that would be fine. Yeah,
So
that much would be fine.
okay,
Okay, so you worked on Terraform as well, right?
yeah, Terraform. I have.
Okay. Can you explain me the Terraform apply command?
Can I explain how Terraform? I'm sorry.
Can you explain me the
How it
Terraform
works?
apply command?
Terraform apply commands. Okay, yeah. Okay. So I use Terraform in my environment as a tool for, automation and to ensure like a smooth running of our processes, right? Basically. Okay, so some of the commands that I use, in my day-to-day activity, I'm gonna say one of them, which is like one of the most common one, is the Terraform apply. Yeah, the Terraform apply. So should I explain what each of them does, or I should just list them? Should
What?
I explain what they do?
No,
I should,
what does it do? What does your Terraform apply
okay,
command
yeah.
do?
Okay, yeah. So the Terraform apply command basically it so it reads configuration files here in the directory, like to understand the desired state of the infrastructure. Yeah, so Terraform now creates like an execution plans that outlines what actions are necessary to achieve the desired state. So this plan can show what resources will be created, what resources will be destroyed, what resources will be updated. So that's one thing it does. So and before making any changes, I think Terraform presents this plan and prompts for me to approve. Yeah. So this step is crucial and it allows me to like do a review of the planned actions and to ensure that I don't just approve things that I'm not sure of. So once I approve the plan, Terraform proceeds to execute the plan that I approved, and then it interacts with the cloud, the cloud providers, and like AWS, Azure, and the likes to make the necessary changes to the infrastructure. And this can actually involve provisioning new resources, modifying existing ones, or even deleting resources that we no longer need. You know, so basically, I think that's how it works. Terraform apply.
Okay,
So
okay. How does Terraform use a state file and why is it important in a collaborative environment?
user states. I'm
How
sorry.
does how Terraform
I'm
uses
sorry.
this state file and why is it important in collaborative environment?
Okay, through Terraform user state file. Why is important? Yeah. So let me see. Terraform user state file is very important. Yeah, and also helps for collaboration. Now, the reasons I'm gonna say, okay, basically, it's very critical. Yeah, because Terraform actually uses this feature to keep track of the state and the configuration of the resources that it manages. So, for example, the Terraform.tf state, essentially it's like I think it's like a database, of some sort, that helps to like store the current state of the infrastructure that is being managed by Terraform. So state file is very important because it's like a reference, if I can use that word, for Terraform to like understand what has been deployed and how it can correlate with the codes that are in my configuration files. Yeah, yeah, that's the word. So this is actually very important for Terraform to determine the changes that are going to be made, when I update my configurations. Secondly, I would say that secondly, I'm going to say that it helps in collaboration, like you mentioned earlier, and helps, in team workflows. So, because I work in a team, and the state file ensures that everyone is working with the same understanding of the infrastructure, and it helps to like prevent conflicts and also prevent, like, I'm gonna say, inconsistencies. Yeah, when multiple people are trying to work on changes. Yeah, so it ensures that there are no inconsistencies. Another thing I would say is it helps to like facilitate um, important features like resource dependency tracking and drift detection. So Terraform uses the state file to like track dependencies between multiple resources, and it ensures that they are created, they are updated, and deleted in the correct order. And I think it also helps to identify drift, which is like when the actual state of the infrastructure like differs from what we defined in our configuration. So it helps to identify that, and I'm gonna say it's vital for accurate and efficient infrastructure, and it ensures that we are consistent. Yeah, it also helps to aid collaboration. When multiple people are working on making changes, and it basically supports essential Terraform functionalities, basically. So
Okay.
that's it.
Um, what is the difference between a local variable and a data variable?
Okay, yeah. So a local variable and a data variable. Okay, yeah. So I'm gonna say local variables in Terraform. Let me see. Look for how best to really. Okay, yeah. Okay, yeah. So local variables, basically, I'm gonna say that you can use them to like define define values that we need to reuse, in that module to ensure consistency, basically. Let me look for an instance. For example, maybe if I have like a common tag or like a configuration setting that I use all the time, like multiple times in the module, I can actually define that as a local variable because it's something that I reuse. So this makes my code more maintainable and more readable, basically, and because I can easily change the value, in one, like, at every point or the other, I can easily change the value, and it actually updates, everywhere the local value is reference, local variable rather. So data sources in Terraform, they're sorry, I'm gonna say data sources in Terraform. They're actually like a way to fetch information, yeah, basically, about existing infrastructure that we don't manage with Terraform. So, for example, I want to like get an information about an AWS, VPC, S3 bucket, and the likes that was not created. That was created, like, I'm going to say, outside of Terraform. I'm going to use like a data source, and the data source would basically allow me to reference external sources without managing them, basically. And this is, I think, important in integrating with existing infrastructure, yeah. And yeah, so where certain resources need to be managed outside of Terraform for any reason at all. Basically, I think that's it.
Okay. So you have worked on EKS as well, right? Kubernetes service.
Yeah, I use Kubernetes.
Okay. I'll talk about a few scenario based questions. Okay. You can answer with respect to EKS. Okay. Okay. So let's say there is an e-commerce platform and it is experiencing massive traffic spikes during flash sales. Okay. And because of
Okay.
that there is a outage, and because of an outage we lose the revenue. Okay. We need a
Okay.
scalable and resilient infrastructure to handle peak loads without compromising the performance. How would you put EKS into this?
Okay. Okay. Let me see. So we are looking at using EKS to ensure that there is steady flow of traffic, where you have massive traffic, and to ensure that there are no downtimes, right? I'm just trying to be sure that I understand your question. Okay, so let me see. I'm going to say for an e-commerce platform, I think the first thing I'm going to do is I would maybe I'm going to deploy an EKS, which is like Amazon's managed Kubernetes service. Yeah, I'm going to deploy that. Yeah, but Kubernetes is actually like a great scenario because it can handle cases like this. Because of its scalability, its resilience, and the fact that it can also support rapid deployment. So yeah, so I'm going to set up like multiple pods, just to host the various components of the e-commerce sites, and this actually can include separate pools for maybe like the front end, the back end, and the database services. So this is actually like microservices, basically. So by using this microservices architecture, we can actually scale each component independently based on their specific traffic requirements and their resource requirements, just to ensure that there isn't so much pressure. So one major thing that EKS does, which is why it's my go-to, is the ability for it to automatically scale an application. And I'm going to, in this case, yeah, the scenario you give, I'm going to use the horizontal pod autoscaler, which will help me to automatically scale the number of pods in a deployment, the replication controller, or maybe like a stateful set, yeah, based on like observed CPU utilization, or maybe other select metrics here, basically. Yeah, so additionally, I think another thing that EKS does is it helps to integrate seamlessly with other AWS services, which will be crucial for this project, based on this scenario that you gave. So, for example, I'm going to use Amazon RDS or Dynamic DB for database services. This would help to ensure that there's high availability and there's high scalability. And maybe like, yeah, Amazon S3 buckets will also come in handy here. It should be able to help to store, I think I would say like static assets, yeah, maybe like the product images, considering that it's an e-commerce website, e-commerce platform. And AWS cloud front, yeah, can also be used here, maybe to like distribute content, yeah, globally, and to reduce load times, to ensure that there isn't an obstruction here. So to ensure reliability, I would also like implement the AWS elastic load balancers. Yeah. So the load balancers will help to like distribute the incoming traffic, across multiple targets, to ensure that there's an improvement in the distribution of network traffic, so that there won't be like an overload, if I have to use that word.
Okay.
So
Okay, that's fine.
yes.
But how can we ensure data consistency during the scaling event? We have something in EKS features, right? What can we use
Okay, to ensure data consistency.
during the
Oh yeah,
scaling events?
so sorry.
During scaling events.
Okay, during scaling events, let me see, to ensure data consistency. Um, I think basically, during scaling events, let's see, let me see. Okay, so I think
You can talk about EKS features. We have one or two features which can help in this scenario, particular scenario.
okay, 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 yeah. So I think I've actually been able to remember something. So I'm going to say maybe like implementing like a distributed databases that are designed for
No,
high availability.
let's not
Okay,
go
that's not
down that line. No.
that's not there. Okay, all right.
Do you
Okay,
know
let me think of some.
stateful set and persistent volume concept of stateful
Yeah,
set? What exactly it is?
stateful set and what
And persistent volumes. Okay,
and consistent volume.
what exactly is a persistent volume?
I'm sorry, I didn't get that. I'm sorry.
What do you mean by a persistent volume?
Consistent volumes.
Persistent, P for parrot.
Okay. Oh, okay. Persistent volume. Okay, yeah. So basically, persistent volume in the context of Kubernetes, right? Okay, so I'm gonna say it's the environment we I think I'm gonna say like it's a crucial concept, especially when we deal with like stateful applications, basically. So yeah, so in Kubernetes, persistent volume is like a piece of storage, yeah, in the cluster, which has been, I'm gonna say, provisioned by an administrator, or dynamically like provision, yeah, using storage classes, yeah, if I'm not mistaken. So it's like a resource in the cluster, just like we have nodes, in the Kubernetes clusters, which are also resources. So persistent volumes, I think they're like plugins, yeah. They have like a life cycle that is independent of any individual pod that uses, the persistent volumes. So what makes it persistent, yeah, as opposed to, a regular volume, is its durability. It's actually very durable, and its longevity as well. So regular volumes are not they are not they are not that durable, and also they are, I'm going to say, ephemeral. Which means they're like tied to the life cycle of a pod. So when the pod is actually done, it means when the pod dies, yeah, that's the word. It means that it's lost as well. But with a persistent, yeah, the data actually remains even after pod dies, basically. And yeah, I think that's it. So it's actually crucial for stateful applications, yeah, that needs for, I'm gonna say, for data to be preserved, basically, and for deployments to be restarted and all of that. So that's it.
Okay, I mean, you can use stateful sets and persistent volume to manage stateful applications and persistent storage across node failures or scaling operations. So that's okay. This would be my last question for today. Let's consider a scenario in which we have a traditional monolithic application. Okay, and it needs to be.
Monolithic application.
Yes, we have a monolithic application and we need to modernize it. Now, in order to
Okay.
do that, we need to migrate to cloud for faster innovation or deployment. Okay,
Okay.
we need a flexible and modular architecture that can handle independent development and scaling for different component. Okay, now how would you use EKS in this situation?
Okay. Okay. So, um, for monolithic applications, yeah. So I use the EKS here for to migrate monolithic applications here to microservices.
Okay.
Basically, let me think of a scenario where I've used it before. Sorry. Okay, so I'm going to say that I'm sorry. Just yeah. So
Okay, I'll help you
um,
get started. First of all, you will deconstruct the monolith into microservice. Okay, that's the
yeah.
first
So
step.
I think I can take it off from there. So yeah. So we break down the monolithic application into microservices. I think we do this so that we can like identify logical components of the application. I think such as things like user authentication, maybe like order management, product catalog, and the likes, and we can separate them into deployable services basically, and this approach makes the application easy to manage, yeah, that's it, and also helps to update and allows for each microservice to, like, I'm going to say, scale independently, based on the demands available. So after defining the microservices, the next step would be the containerization. So I'm going to like package each microservice into its own container. We use Docker for containerization in my environment. So containers are actually very key because they help to, I think I'm going to say, like, encapsule the microservices and their dependencies to ensure that there's consistency across the different environments, basically. And when the microservices are containerized, then I'll move to deploy them on Amazon EKS. So, of course, we know EKS is a managed Kubernetes service, which simplifies the process of running the Kubernetes on AWS without us needing to install it or to maintain our own Kubernetes control plane, basically. So I think it's a great fit for this scenario because of its scalability and the, I would say, robustness. Yeah, because we need a robust application for what we are doing. Um, so what else? Yeah, so in the Kubernetes pods, we are going to host one or more containers of the microservices in the pod, and I'll also configure the Kubernetes services, that which provides like stable endpoints, yeah, basically for I would say communication between the microservices because they have to be able to communicate with each other. So one thing I like about EKS is the fact that it can handle the orchestration of these different containers. It can also help to manage their deployment, and it can scale as well, and it also helps to monitor, because monitoring is a key aspect. We have to make sure that all the pods are healthy, and yeah, for the calling parts, yeah, I'm gonna say that I would actually use Kubernetes horizontal pod autoscaler, and the reason I'm gonna use it is because it can automatically adjust. Yeah, I'm gonna say the number of pods in a deployment based on the CPU utilization or other metrics here, basically. So this can also help to make sure that our microservices can maybe scale out, maybe or scaling basically, depending on the load that is available. So, and this is actually key for handling traffic effectively.
Okay.
Um, what? Yeah,
I'll just walk through. As I told that the first step would be to deconstruct the monolith into microservices. Then what you can do is you
yeah,
can deploy them to EKS. Okay. Now
yeah,
each microservice that you broke down will be containerized and deployed as a separate pod. Okay. This
yeah,
will allow independent scaling and updates. You can utilize
yeah,
a service discovery mechanism like Kubernetes DNS to enable microservice communication with each other. You can manage the configuration with tools like config map and secrets for centralized control and secure storage. Okay. Now, if you ask me what exactly is the benefit of it, the benefit is improved developer productivity and faster time to market. This will increase the application resilience and fault isolation, easier scaling and deployment flexibility. It will also simplify the application maintenance and the upgrade. Okay, so that's pretty much
yeah.
about it. All right, so yeah, I think I'm done.